All righty. We are going to continue on with our knowledge on area, but we are adding in that information on perimeter. So, might I strongly encourage, if you do not have your perimeter notes that we took this morning, to go get them, because they'll be very, very, very helpful to you. Okay, so have those with you. That way you can remember the difference between area and perimeter. Also helping you remember the difference between area and perimeter is our vocabulary. So without further ado, let's go ahead and watch this and review. There I go with those rhymes again, kids. Woo, I'm on fire. All right, here we go.
It's the year 2060 and you're colonizing Mars. You're about to buy a plot of land, but you have a dog and you want to make sure he has enough space to run around. You also want to build a fence so he can't escape. So first you want to know how big the backyard is, and then you want to know how far it is around. To figure this out, you have to find
the area, that's the space inside. For a rectangle, its length and width are multiplied. And perimeter, the distance around a shape. Just add the sides together and then you'll be great with the area. That's the space inside. For a rectangle, its length and width are multiplied. And perimeter, the distance around a shape. Just add the sides together and then you'll be great. Yeah, here I am on Mars, trying to find out the size of my backyard. Well, it's a rectangle, right? So what if we cut it into squares of the same size that are 1 unit long by 1 unit wide? These are called square units. Add them all up, surprise! You got 72 square units, because that's the unit we're using. But who has time to count squares? Length times width is the quickest way to get there. Yeah, that's how you find the area. A nice little formula that'll take care of you. And I need to hurry cause my dog is starving. Let's find the area so I can feed Marvin. My yard is 9 feet long by 8 feet wide. I get the area when I multiply each side. And 9 times 8 is 72. But here's another way for you to think it through. Basically you take the rows and figure how many square units fit inside of those. Yo, my backyard is wide, 8 feet. So that's 8 rows with 9 square units in each. So multiply the 8 rows by the 9 square units, you get 72. Yup, you knew it. The area, that's the space inside. For a rectangle, its length and width are multiplied. And perimeter, the distance around a shape. Just add the sides together and then you'll be great with the area. That's the space inside. For a rectangle, its length and width are multiplied. And perimeter, the distance around a shape. Just add the sides together and then you'll be great. Now I've got my area for my yard on Mars, and there's plenty of room for Marvin to live large. But now I need a fence, cause I heard the animals on Mars could be intense. So I'll need a perimeter, the distance around my whole yard. How do you get it? Yeah, just add up the length of the sides. 9 plus 8 plus 8 plus 9's a perimeter of 34 feet. And oh yeah, that's regular units and not units squared. So let's take a look from another angle. To get the perimeter of a square or rectangle, you add 2 widths plus 2 lengths. Here's a formula, don't forget to say thanks. 2 times length plus 2 times width to get a square or rectangle's perimeter quick. So let's try it with my Martian backyard. Come on, get ready y'all, it's not that hard. 2 times the length of 9 is 18, and 2 times the width of 8 is 16, and 16 plus 18 is 34. Now if I could stop Marvin from making a dirty floor. Come on Marvin. Seriously.
Oh, that Marvin making a dirty floor. All right, so you have just reviewed your area and perimeter. Who can tell us the difference between area and perimeter? What is the difference between area and perimeter? William?
The difference between area and perimeter is area is the inside of a shape and perimeter is the outside.
Perfect. So if you were to think about it in terms of a building or a house, the area would be the carpet or the tile on the floor. That's inside. The perimeter would be the walls on the outside of the building that make the shape. So it's the outer space of the shape. Levin, did you have something to add to that?
about the vocabulary, but it's not vocabulary, whatever. I can't talk today. Speaking of animals, there, Carlos trying to get his collar off, and he was just in a very weird position.
Oh, I see. Well, the collar would be around the perimeter of his neck because it is on the outside edge of his neck. Great. What about the difference between how you solve area and perimeter? What's the difference between that, between how you solve area and perimeter? If I want to know the area, what am I going to do with the length and the width on the area? What am I going to do? We've been working on this for a week and a half. People, don't make me cry. If I want to find the area, what do I do to the length and the width? Lily?
You count them up and multiply them.
Multiply them. That is correct. I got to figure out the length. I got to figure out the width, and then I multiply those together, and that will give me square units. Okay. What about perimeter? Notebooks. What about perimeter? When I want to find perimeter, how might I use math to solve that? How would I do that? Christopher, what am I going to do?
As you're like doing area, you do it like from the outside.
Yes, it's the outside. It's not the inside of the shape. Good. So what am I going to do with the lengths and the widths on the outside of the shape? Perimeter equals what? What am I doing there? Aiden G, look at those notes. What do I do with the lengths and the widths?
You add them.
I add them just like I would if I was creating a fence or a Minecraft border, right? I would count how many blocks or units I would need to go around the area that I want to protect, and I would add that many. So perimeter, we are adding. Thank you, Aiden G. I guess even on your Fortnite games too, you crazy gremlins, when you're building your towers, you got to know the perimeter to see how many things and materials you want to go around it. All right, so we are going to practice together today in various forms with me in your breakout rooms and independently, okay? As a final review of your, good morning, Ms. Williams, of your area and perimeter, I wanted to bring us back to our paper example, right? Remember, we talked about how this has an area, and if we were to measure this, it would be a certain amount of space. Now, I can also tear this piece of paper, and if I keep both pieces, the area is the same. Look, I would still have the same amount of space, whether it was put together this way or if I rearranged it this way. Even if I made it so it wasn't a rectangle and it was joined this way, the area is the same. There's the same amount of paper here. Now, here's what we're going to focus on with differences today. If we were to add up the lengths and widths of this when it's put together, that would be different than if we were to add all of the lengths and widths when it looks like this. Now I've got these extra sides that I didn't have before. And it could go even farther. Same amount of paper. If I were to tear it like this, still have the same amount of space, but let's say I wanted my paper to be in this shape, like a bunny's face. Okay, now we have the same amount of area. There's still the same amount of paper here, but the perimeter, that outer edge, is way longer now because I've added more sides, okay? So today, we're going to be looking at figures that have the same area. They have the same amount of space, but because the way that they appear is different, we're going to find that they have different perimeters, okay? So that's what we're going to look at today. On your seesaw, there is an assignment that we are going to work on together in various forms. There's going to be some parts you're going to do with me. There's going to be some parts you'll do independently. And then I'm going to pop you into some parts with your breakout rooms, okay? So please right now go to your seesaw and click on that activities. And right up top, you'll have an activity called rectangles with the same area, different perimeter. Okay? Rectangles with the same area, different perimeter. And remember, when we're doing work together, I recommend minimizing the size of your screen down so that you can put zoom over here in the empty space and you can see your seesaw work right here so that you don't have to flip back and forth to copy. Okay? So remember that little skill there. All right, I'm going to go ahead and click add response. Hopefully you have your response opened by now. Yes, and according to Dino, most of you do. Woohoo, great job following along. All righty. When I click on our instructions, we're going to see the overview of what we're going to do. We've added the response. As always, we're going to review our success criteria. Today, I want you to think about the vocabulary specifically that you are going to use. When you're working in your breakout rooms and on your explanations, if you're just saying, oh, it's this side, it's this side, people can't see your screens, remember? We're not in person. So we're going to need to be very specific with that vocabulary by saying the length, which we know is the longer side, the width, which we know is that shorter side. So think about the vocabulary that's going to help you. Then we will do 2 through 5, slides 2 through 5 together. We'll watch some videos on slides 6 and 7, and then it's going to be time for you to get to work, okay? All right, so I'm going to play our success criteria, and after we're done listening to this, I want you to tell me what vocabulary is going to be important, okay? What vocabulary do you want to try to practice using today? All righty, here we go. Today's goal is?
Today, you have a specific goal, and that goal can be found on target 3.2. Identify and draw rectangles with the same area and different perimeters. You also will be using math vocabulary to talk about this area. The area, the length, grid lines, perimeter, unit squares, and figure. Remember that rectangles are quadrilaterals. We also need to remember that you will be finding the area of rectangles with whole number side lengths by modeling with unit squares and by multiplying the side lengths.
Alrighty, what vocabulary do you want to try to get more specific with today? Share with me your vocabulary goals. What's a word that you're going to make it your goal to use? Aiden G, what word do you want to make sure you use today as you're working?
I want to make sure I use area.
Okay, and tell us, what is area?
Area is a rectangle or square that you put lines in and you figure out what's your total amount of what's inside of your equation.
So you just shared with us a way to find the area as well as what it is. Area is the amount of space inside of that shape. And we've been working with squares and rectangles. So thank you for sharing us how we can solve it by counting up our grid lines. All right, Aiden G is going to use area. If you're partners with Aiden G in that breakout room today, you better make sure he says that. Another vocabulary goal. What other word do we need to use today to complete our work? Levin, what word are you going to use?
Width and width and length.
Can you tell us what widths and lengths are?
Length is the size, length and width are the size of your area.
So they can be used in area, and as we learned today, they can be used in perimeter. So they are the names of the sides of the shapes that we are calculating today. Remember, ladies and gentlemen, that length is going to be the longest side. Do you hear that? Length, long. Length is going to be the longest side on your shape. So when you're in your breakout room, and if Levin says, oh, the length is, he's telling you about that longest side. If Levin talks about the width, that is going to be the shorter sides of your rectangles, okay? All right, good vocabulary. Remember, you can come back to slide 1 if you need more specific information on the words you should be using. Slide 2 lets you know we're doing this together. Okay, let's activate our prior knowledge. Let's go to slide 3. Slide 3 tells us to review how you find the perimeter of a rectangle. Remember, if your teacher is writing, you are writing. So go ahead and grab that writing tool. I don't care what color you use. Get your favorite color. Make it fun. My favorite color is actually orange and teal, so I'll go with orange. Okay. Reviewing the perimeter, we have our formula right here. Remember, our formula uses symbols to tell us how to calculate something. In this case, it's the perimeter. We're going to use the perimeter to find the length of the outside edges of this shape. So we're going to calculate both lengths and both widths. Okay? Get your fingers ready. I'd like for you to count the length of this rectangle and hold up with your fingers how long the length is. Count the length and show me with your fingers on camera what our length of the rectangle is with your fingers. Have your answers in 5, fingers up in 4, counting that length in 3, ready to go in 2. You're so excited, I can see it. And 1, what's the length? Go, length. Okay, I see a 5, I see a 7, I see a 5, I see a 3, I see a 10. Ooh, somebody did double the lengths. Okay, let's look. Length, ladies and gentlemen, remember we have that cursive L that represents the length. When I count the edges or the squares, I have 1, 2, 3, 4, 5. So my length is 5 units. Okay, so I should have seen a 5. Some of you held up a 10 because you know that in our perimeter, it's double the length because we count the top and the bottom, both lengths. So that does give us 10, but our specific length is 5. Okay, so let's look at our formula. Our formula says perimeter is length plus length. So over here in our blanks, let's add both lengths. We have 5 plus 5. That's our perimeter so far, but we have to get the width because as we know, if we were going to make walls on a building or a fence for our backyard so that our dog doesn't get away and we only put a fence here and here, little doggy's going to go running away and get out anyway, right? Or it's going to get super cold in our house because we're missing 2 walls. So that won't work. So now let's count our widths. We know our widths are the shorter ends of our shape. So look at your widths. Go ahead and count the length of 1 width. How many units is 1 width? Get ready to show me with your fingers. 5, fingers in 4. Ready to go in 3, count those edges in 2, and show me those answers. How many units is that width? Good, okay, we're a little bit more clear, and I see some of you are holding up 2 3s because you know that we have this width on the right side and this width on the left side. Our width is 3. 1, 2, 3 units. So we are going to record that as the width on the left is 3, the width on the right is 3. So to find the total perimeter, we have 5 plus 5 plus 3 plus 3. This is where you get to do some mental math. I know that 5 plus 5 is 10, and I know that 3 plus 3 is 6. So my perimeter is equal to 16 units. And remember to add that label, guys, because if you don't, I'm going to think you have 16 purple unicorns flying through space. And remember, that's going to make me very happy, but it's going to make you very wrong. Okay? That label, make sure we have that. That way we know what we are measuring. Okay? Josh is finding the perimeter of his Mountain Dew can. Questions on perimeter and how we find that by adding all 4 sides, the distance of all 4 sides. Questions? concerns, comments? Okay. Taking the same rectangle on slide 4, let's look at the area. Same rectangle on slide 4. You guys already know the lengths and widths. You just found it with the perimeter. So I am going to pop you into some breakout rooms, and you are going to go find this area in 2 minutes because you guys are area experts by now. So I'm only going to give you 2 minutes to get this done. Okay? 2 minutes to find the area. When you come back, you will check your answer with me.
Understanding of how to create 2 rectangles with the same area or the same square units inside of a shape, but a different perimeter or a different amount of space around the outside edges of the shape. To do so, we're going to take a look at this example. Today, you will create 2 rectangles with different lengths and widths that have the same area that has been given to you. In this case, the area is 12. Then you are going to record the perimeter or the space around the shape to describe the rectangle's perimeter. Then you will make sure that you count both sides of those corner squares inside of that perimeter. And finally, you will fill in the equations. So as you can see, we have been asked today to find an area of 12. So we're going to need 12 of these square units. In order to start building a rectangle, I have to first think about my possible lengths and widths. We know that in area, we multiply the length and the width together. So I could start with 1 because we know that in multiplication, any number times 1 is itself. The problem is I don't have 12 squares of a workspace. So 1 is not going to be my best bet. So now I can think about moving up a factor to 2. I could create row of 2 or a column of 2. Let's see if 2 will help me get to 12. 2, 4, 6, 8, 10, 12. Hey, it will. So I can count by 2s and get up to 12 square units. So far I have 1, 2, 3, 4, and I'm going to keep going until I get to 12. 5, 6. I like to record how many I've added so far because that helps me keep track. If you're able to do it without that, that's totally fine. 9, 10, 11, 12. Beautiful. So just like we predicted, we were able to get to 12 counting by 2s. So we have a width of 2 square units, and we have a length of 1, 2, 3, 4, 5, 6 square units. So my area that I used, or the dimensions that I used to find an area of 12 are 2 times 6 is equal to 12. And again, we have to have our label that tells us we're working with area. Otherwise, it could be confusing and perceived as perimeter or some other type of object.
Okay, so I want to kind of review that really quick. Did you notice why I could not do a width of 1? Why could one of my rectangles not be a 1 inside of this space that I've been given? What would have gone wrong there? Terrence? Why couldn't I do 1?
Because you wouldn't have got the whole answer. It wouldn't have been right.
So I could have gotten the correct answer, but I like that you said I wouldn't have had the whole part, right? There's not enough space here. Look, I don't have 12 unit squares. So I've kind of got some confines. I've got some barriers that I've got to work in between in my workspace. So 1 times 12 would have been an area of 12, but I've only been given this small space. So I've got to think of different dimensions that were going to give me that, which is why I moved to those 2s. Okay. So we started at 1. We decided our space isn't big enough. So we went down to 2. And guys, that can happen to you in real life. Like I shared with you earlier, when you guys are building your own fences one day, or you've got a company that you're trying to run and they say, here's your land, put your building on it. You might want your building to be this long, but if they only give you this much land, you're going to have to figure out how to change that around. Okay. So you might have to change the dimensions of your rectangle to fit inside of that workspace. Okay. Here's how we find the perimeter coming up next. And remember, this is the newer part of our skill.
So 2 times 6 gives us an area of 12 square units. We know that when we're adding our perimeter, we're going to take each of the 4 sides, both of our lengths of 6, and both of our widths of 2, and we're going to add those together. What I like to do when I'm counting the perimeter is put a tick mark on each edge between the square units. So 1, 2, 3, 4, 5, 6. I have to be careful that I'm not counting the number of squares because that would leave out this edge of the same square. So I'm counting the number of edges or spaces between the unit squares.
That's very important. And it is a very, 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 very common third grade mistake. My third graders start counting the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Guys, that's the area. You just told me what's inside, right? So you've got to count those outside edges, okay? Because remember, if you only count the squares, you're only telling me you're going to put a fence here and you're going to put a fence here because that's the squares that you counted. You didn't count the sides over here. Uh-oh. And remember, if we have our little dog, Marvin from Vocabulary, and he doesn't have a fence, where's he going to go? Woo! Gone. Bye-bye. Okay? So we've got to make sure that we're counting those edges as well, not just the squares.
So this has 2, so we've got 6, 7, 8, 9, 10, 11, 12, 13, 14. There's that tricky edge again. 15, 16. So our perimeter is going to be 16 units. We found that by adding both of our lengths, 6 plus 6, and both of our widths of 2 plus 2.
Okay? All right. I'm going to throw you into some breakout rooms. There is a question that you are going to answer. Okay? The question is, how do you find the edges in perimeter? And bonus points for using some of that math vocabulary we talked about. Okay, how do you find the edges in your perimeter? How are you going to calculate those? Okay, all right, I'll type that question to you. I'm going to call on some people randomly to share when we get back. How do you find the edges in perimeter? Go. All right. Question was, how do you find the edges in perimeter? What's something that you can do to figure out the answer? Okay, how can you do this? William, you said it's not enough time in your group. I'm sorry, but that tells me that you have a lot to say. So share with me, kiddo. How can you find the edges in perimeter? What's a strategy?
You can find the edges in perimeter by using multiplication.
That's going to give me the area, but I think I remember what you're saying about multiplication with 2 times. Be more specific.
Well,
look, we wrote it in our formulas. Does this help you remember? Ooh, I hear his notebook rustling. I'm getting happy right now. He's got his notebook ready to go. I can technically use multiplication to find perimeter, but it's a very specific way. What do I have to multiply?
The length and the widths.
I do, and I have to do each of them 2 times because rectangles have 4 sides, 2 lengths and 2 widths. William with the advanced formula reminding us, okay? So multiplying 2 of the lengths and adding them to 2 of the widths. How else can I find perimeter? What can I do with those edges? Josh, how else can I find perimeter? What can I do? I don't think we can hear you. Your headphones, remember? Unplug those so we can hear you. What am I going to do to the lengths and the widths? There we go. Now I can hear you.
I don't know.
Add them all together. So length plus width plus width. That's how we can find those edges. Okay. All right. Now, just like this piece of paper, right, that we've changed the shape of, we're going to change the shape of 12 square units to get a different perimeter. Still going to have the same area, but that perimeter is going to be different. And here is how that looks.
As we know, we're not done with this problem because our directions asked us to create 2 rectangles. So far, I've only created 1. I've used the factors 2 and 6. So when I create a purple rectangle, I can't use the factors of 2 and 6.
We catch that? We're making it different. My rectangle can't look like this. And that means I can't cheat and just do this either. Hold on, I got to put my piece of paper back together. All right, I can't do this. I can't just go, psh. That's the same rectangle. You just turned it on its side. Remember, I'm Miss Sousa. Look at me. I'm still Miss Sousa, okay? We want a completely different one, not one that's been turned. We want one that has been changed, okay? Here's how we're going to change that rectangle.
When I made the last rectangle, I got rid of 1 as an option because I don't have 12 spaces in which to work. 2 has already been used, so now I'm going to think about creating a rectangle with a dimension of 3. So let's think about 3's. If I multiply by 3's, will I say 12? Will I get to 12? 3, 6, 9, 12. I will. And I did that by counting by 3's 4 times. So I'm going to go ahead and fill in 4 inside of each row of my rectangle. Then I can just fill in the rest of my rectangle and know that because I was careful with my dimensions in length and width, I'm going to have a total of 12 square units. Now I'm going to label my length and my width. I can see that I have a length of 4 units. I can see that I have a width of 3 units. So my area is equal to 4 times 3, which we know gives us 12 square units, as we've proven in our illustration and as was described for us in our directions. To find the perimeter, I'm again going to count those spaces between the square units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's that tricky corner. 12, 13, 14. So again, we're very careful to make sure that we count each time the edge of a shape that is shown, whether it's on the same square like this blue corner is down here. There are 2 edges of this square on the outside perimeter of the shape, so we count both. So now I will record my perimeter equation, which is my lengths of 4 and 4 and my widths of 3 and 3. 4 plus 4 was 8. 3 plus 3 was 6. 8 plus 6 is equal to 14. And again, we're working with units. So whether I count the edges 1 by 1 or I add them using the dimensions, I'm going to get the same answer. We can see that we have 2 rectangles with the same area of 12, but different perimeters. Our orange rectangle has a perimeter of 16 units. Our purple rectangle has a perimeter of 14 units.
Okay, same amount of unit squares, but we've changed it around. All right, you're getting ready to practice one of these with a room, a buddy. Okay, I want you to go to slide 9. Okay, on slide 9, you are going to do a think together. All right, think together. you are going to create two rectangles with different lengths and widths that have an area, which is the space inside, of 24. So you want to think right now, what numbers multiply to equal 24? Think about that now. Then you're going to record the perimeter by adding up both lengths and both widths. Okay? You're going to fill in those equations. Questions about this expectation before I send you into your breakout rooms? Okay. I am going to be hopping in and out of breakout rooms to listen to your progress and to see if you are in fact thinking together. We've been doing a lot of breakout room practice with making sure we are unmuted, making sure that we are actively sharing our ideas. Okay, I want you to make sure that you are continuing in that skill. Unmute and actively share your ideas. Okay, all right, let me get these set up for you and then I will be popping in and out. You are going to work on slide 9 only from you kiddos. I noticed when I was hopping in and out of breakout rooms that we are doing a fantastic job building our models. The models are beautiful. You're able to figure out those lengths and widths that multiply, and you are able to figure out how to create that in picture form. We're struggling a bit on the perimeter, and that's okay. This is a newer skill to us. So here's what I need from you right now. I need for you to click the orange check and save your work as a draft. This evening, I'm going to look at what you came up with so far, and I'm going to give you some feedback. So look for that comment from me. And then tomorrow, we're going to go back into breakout rooms and continue working on this. We need some more practice with this skill, and that is okay. So click that orange check, save it as a draft, and then we are going to take a look at this tomorrow. And tonight, I want you to look at the comment I'm going to give you for some feedback, okay? I'm going to let you know what you did well and anything we need to keep practicing or fix, okay? All right. So this will be completed tomorrow. Today, I'd like for you to continue thinking about area and perimeter. You have your vocabulary as an option to practice. You also have the videos that we've done together to watch. And you can, of course, always be thinking about the perimeter and area of objects around you.